Click the bell icon to get latest videos from Ekeeda.
Hello friends, in previous videos we have studied the two methods of braking, that is rheostatic braking and regenerative braking. In this video we are going to study another method of braking, that is plugging. In plugging, basically the supply terminals are reversed. Now let us see the method of plugging for DC shunt motor. If we see here, this is the separately excited DC shunt motor. Here the terminal voltage is reversed. In motoring operation, this polarity in positive and negative. But if we see here, the polarity is reversed to negative and positive. In this case, what will happen is the total voltage will act in positive direction. Hence, the back EMF EB and voltage will get added. So we can write the equation as IA is equal to V minus EB divided by RA. This is the operation of the normal motoring region. In the plugging, this equation will change as IA equal to V plus EB divided by RA. As we can see, the voltage drop has increased. Hence, the armature current will also increase. This armature current will not only increase, but it will also flow in the reverse direction. If we see here, the armature current will flow in the reverse direction. Hence, the high amount of armature current will dissipate in the form of loss in the heat RB. If we see here, the external resistance RB is connected. Due to this external resistance, the current will start to flow in the RB. When the current flows in the RB, the power will be dissipated in the form of heat losses. We can see here that initially this machine was operating as a motor, but due to the plugging, the motor is not operating as a generator. Due to this high value of current IA, the high braking torque is produced. Due to this high braking torque, the motor will start to rotate in the reverse direction. Now let us see the plugging for DC series motor. In case of DC series motor, for carry out the plugging, we have to replace or reverse any one terminal. That is, either we have to reverse the field winding terminals or we have to reverse the armature winding terminals. The diagram is as shown in figure. If we see here, the armature terminals are reversed, whereas the field terminals are kept constant. Again, in this case, the current will increase because your EB and voltage will act in same direction. The motor will start operating as a generator. Once the motor starts operating as a generator, whatever mechanical energy will get converted into electrical energy. The external resistance RB is connected. The increased current will flow through this external resistance RB. Hence, there is a huge amount of power loss in this external resistance RB. The external resistance RB should be designed in such a way that it can carry a very high amount of armature current. Now, as the braking torque is applied, even though the speed of motor becomes zero, the braking torque does not become zero. As a result, the motor does not stop, but it continues to rotate in the reverse direction. In order to let the motor stop, we have to disconnect the motor from the supply when its speed is near to zero. This is done with the use of centrifugal switches. If the motor is not stopped at the speed equal to zero, then the motor will continue to rotate in the reverse direction because of the braking torque. By using the centrifugal switches, the motor is immediately disconnected from the supply. The main drawback of this method is that there are huge amount of losses, not only of the load current but also due to the armature current. Due to the value of external resistance, the losses are occurred in this external resistance in the form of heat. Thank you friends for watching this video. Stay tuned with Ekeeda and do subscribe our channel Ekeeda. Thank you.